Hey kids, so our topic for today is law of conservation of momentum. But first we'll check out what is momentum. Okay, so what is momentum? If there is an object of mass m and its initial velocity is u meter per second, and if we apply a force to it, the mass remains the same but the velocity changes from u to v. Okay, so because of change in velocity its motion changes, right? So motion of any object depends upon momentum. Okay, and motion of any object depends on momentum. And what does momentum mean? It's mass into velocity. Okay, so if we have to find out initial momentum, then we will say initial momentum is mass into initial velocity, and if we have to find out final momentum, then it is mass into final velocity. So P, that is momentum, is equal to m into v always. Okay, so what do you mean by law of conservation of momentum? Law of conservation of momentum. It says that if there are two objects, okay, and if suppose this is A, this is B, let mass of object A be m1, initial velocity u1, final velocity v1, acceleration a1, okay, and the force which object A will exert on B if they collide, let it be f1. Okay, let mass of object B be m2, initial velocity u2, final velocity v2, acceleration is a2, and if the object A is applying some force action on B, then B will give reaction according to Newton's third law of motion, that every action has equal and opposite reaction. So remember, this is reaction force and this is action force. Okay, so having said that, let's start with our derivation for law of conservation of momentum. Okay, so let's start. According to Newton's third law of motion, what is Newton's third law? That reaction force is equal to action force and both are opposite in direction. Every action has equal and opposite reaction. Okay, so reaction force is equal to action force but they are opposite in direction. Okay, so we generally take minus sign when we have to show that something is in opposite direction. Okay, so what was reaction force? No, reaction force was F2, and what was action force? F1. Okay, so this is minus. Do you know what F equals to m into A? We have already covered this in one of our videos. F equals to m into A. Father is equal to ma, right? Okay, no gender bias. So F2 will be what? Okay, force applied by object 2 is equal to mass of object 2 into acceleration of object 2, and this will be mass of object 1 into acceleration of. We already know this, that acceleration is what? Rate of change of velocity, right? Change in velocity upon time. So what will be A2? A2 will be V2 minus U2 upon time. M1, what is A1? A1 is V1 minus U1 upon time. Okay, what is interesting is, okay, we have M2, V2, U2, M1, V1, U1, but we have T, okay, not T1 and T2. Why? Because if object A is banging with object B at suppose 4 o'clock, okay, so what will be the time when object B is giving reaction force? 4 o'clock, right? Okay, time of collision remains same, so that's why we don't use T1 and T2. Okay, so it's divided by T, okay. So in maths what we'll say is k multiply by T on both the sides. This T gets cancelled. What remains is M2 V2 minus U2 and minus M1 V1 minus U1 con. Okay, so multiply M2 V2 plus into minus minus M2 U2 minus M1 V1 minus into minus plus M1 U1. This is minus this side, so when it shifts there, so it's M1 V1. Okay, this remains here plus M2 V2 M1 U1 plus M2 U2. So this is minus here, goes that side, and this minus here, this side. So this happens. What is it? What is mu? Mass into initial velocity of the first object. What is m2 u2? Mass into initial velocity of second object. m1 v1, mass into final velocity of first object, and m2 v2, mass into final velocity of second object. It means that the final momentum, the sum of final momentum, okay, of both the object is equal to sum of initial momentum of both the object, right? So the total momentum of the entire system after collision is equal to total momentum of the system before collision. Okay, so that's how we can say that in case of collision between two objects, the momentum is always conserved. Okay, for example, let's say that okay, suppose there's a kid, okay, and he pushes another kid. Okay, so if this fellow has some velocity here, high velocity, okay, initial velocity, after getting banged to this other kid, okay, its final velocity will be decreased. Okay, but if this kid is standing here, okay, so it has low initial velocity, maybe 0. Okay, but after getting hit by this kid, his final velocity will be more, right? So if suppose both the kids have same mass, okay, so initial momentum of this kid will be mu, and as its u is higher, its momentum will be higher. Okay, after the collision, okay, its momentum will be mv, which will be lower. Okay, but it's opposite in case of this fellow. Okay, its initial velocity was low, so its initial momentum was low, but after the collision its final momentum got increased, right? Okay, suppose इसने इसको धक्का मारा, इसका वेलोसिटी कम हो गया बट इसका बढ़ गया, तो इसका मोमेंटम कम हो गया बट इसका बढ़ गया. Okay, so if we add the initial momentum of both of these, okay, इसका ज़्यादा इसका कम, will be equal to after the collision the sum of their final momentum. इस बार इसका ज़्यादा इसका कम. Okay, so do your best. We'll see you in our next video.